our channel Satya's Chemistry. Today our topic is Tautomerism. Tautomerism is a functional isomerism. Functional isomerism means molecular formula of the compound is same, but compound should have different functional groups are called functional isomerism. Tautomerism is a functional isomerism. Tautomerism is nothing but interconversion of two different structures due to migration of hydrogen atom. Okay, tautomerism is nothing but interconversion of two different structures due to migration of hydrogen atom. In tautomerism, hydrogen atom is migrating from one polyvalent atom to another polyvalent atom. This leads to dynamic equilibrium. Okay, so when hydrogen atom shifted from one polyvalent atom to another polyvalent atom, this leads to dynamic equilibrium. The resulting compounds are called tautomers or tautomerides. Okay, the resulting compounds are called tautomers or tautomerides. Example, acetone. So if you take the example acetone, the formula of this compound is C double bond O CH3. This is acetone. So what is the meaning of tautomerism? Tautomerism means interconversion of two different structures. Okay, so here hydrogen atom is migrating from one polyvalent atom to another polyvalent atom. Polyvalent means more than, if a compound have polyvalent atom means atom have more than one valency. We call it as a polyvalent atom. That means here carbon valency is more than one. In similar case, oxygen valency is more than one. That's why we are calling this polyvalent atom. Polyvalent atom means atom contain more than one valence is called polyvalent atom. In tautomerism, hydrogen atom is shifting from one polyvalent atom to another polyvalent atom. See here, hydrogen atom is shifting from carbon to oxygen. So why? Oxygen is a more electronegative atom, so it attracts hydrogen atoms towards itself. Okay, so in order to maintain 5 bonds, single bonds or electrons, this 5 bond is shifting from here to here. So the resulting compound structure is like this. Tautomerism forms dynamic equilibrium. So this is the dynamic equilibrium. The resulting compound is CH2 double bond COH single bond CH3. This is enol. So double bond, due to the presence of double bond in OH group, so we call it as a enol form. This is the enol form. Here the functional group is keto, so we call it as a keto form. So tautomerism we call it as a keto-enol tautomerism. Okay, so in every case we don't call it as a keto-enol tautomerism. If the function group is keto, then we call it as a keto-enol tautomerism. Otherwise we simply call it as a tautomerism. Okay, so tautomerism forms a dynamic equilibrium. Okay, so this is called dynamic equilibrium and we indicate it as a K equilibrium. What is the meaning of dynamic? Dynamic means isomers are present in equilibrium position are called dynamic. Okay, so dynamic means isomers are present in equilibrium position. See, this is the keto isomer and this is the enol isomer. So these two are present in equilibrium position. Both are in equilibrium position. They are moving from one direction to another direction, left to right, right to left. That's why we are called it as a dynamic equilibrium. This equilibrium is not static. Okay, is it clear? So tautomerism forms a dynamic equilibrium. It moves from one direction to another direction. Okay, so here this hydrogen we call it as a alpha hydrogen. So what is the meaning of alpha hydrogen? Alpha hydrogen means the hydrogen atom which is attached to the alpha carbon are called alpha hydrogen. What is the meaning of alpha hydrogen? The hydrogen which is attached to the alpha carbon. So we call it as a alpha hydrogen. So for example, if we see the same above example, so once again we are writing here. So the structure of acetone is C H H H C double bond O C H H H. So alpha hydrogen. Alpha hydrogen means the hydrogen which is attached to the alpha carbon are called alpha hydrogen. So what is the alpha carbon? Alpha carbon means the carbon atom which is just adjacent to the functional group are called alpha hydrogen. Alpha carbon. See, just adjacent to the functional group. In acetone, this is the functional group. What is the functional group? Keto. Keto is a functional group. Just adjacent to the functional group. Which carbon is adjacent to this? This carbon is adjacent to functional group. So we call it as a alpha carbon. In right side also, this carbon is a alpha carbon. Why? Because this is just adjacent to the functional group. These hydrogens are called it as a alpha hydrogen because these hydrogens attached to the alpha carbon. Here 3 alpha hydrogens are there, and here also 1, 2, 3. 3 alpha hydrogens are there. In tautomerism, very important point is that alpha hydrogens involved in the keto-enol tautomerism. If compound doesn't contain alpha hydrogen means it doesn't shows tautomerism. Is it clear? So alpha hydrogens, only saturated alpha hydrogens participates in tautomerism. Here I am saying, here we are saying that saturated alpha hydrogens. That means what we say is saturated means sp3 hydrogens. Okay, that means the hydrogens contain only single bonds that doesn't attach with any double bond or triple bond are called saturated hydrogens. Only saturated alpha hydrogens are involved in tautomerism. Is it clear? So, and another important condition is that compound should have electron withdrawing groups like keto, nitro, cyano, ester, etc. So these compound shows tautomerism. Okay, so tautomerism means interconversion of two different structures, interconversion of two different structures due to migration of alpha hydrogen atom are called tautomerism. Okay, is it clear? So now we will see characteristics of tautomerism. Okay. Characteristics of tautomerism. See, so this is the characteristics of tautomerism. First characteristic is tautomerism is caused by the oscillation of hydrogen atom between two polyvalent atoms present in the molecule. Okay, the change is accompanied by the necessary rearrangement of single bond and double bond. I think this point is clear, and I am explaining once again. See, tautomerism is caused by the oscillation of hydrogen atom. Again, we are taking acetone example here. C H H H C double bond O C H3. So here oscillation of hydrogen atom. So this alpha hydrogen is shifting from carbon atom to oxygen atom. That means here we are saying two polyvalent atoms. So one is carbon atom and another one is oxygen atom. So hydrogen is shifting from polyvalent carbon atom to polyvalent oxygen atom. The change is accompanied by the necessary rearrangement of single bond and double bond. So in this compound, in order to maintain 5 bonds and electrons single bonds, this 5 bond is shifting from here to here. So the resulting compound is looks like C H2 double bond C OH CH3. This is enol form. Okay, this is keto form. Why? Because this is the keto function group. This is the enol function group. En means double bond, ol means OH function group. Okay, so first I think first characteristic is clear for you. Okay, is any doubt? So next point is tautomerism is a reversible intramolecular rearrangement. Reversible means the reaction should take place right to left, left to right. So tautomerism is a dynamic equilibrium process. Okay, so that means here reaction takes place left to right and right to left. And here one very important point is intramolecular rearrangement. See here, intramolecular. I think you all know that what is the meaning of intramolecular? Intramolecular means if the rearrangement takes place within a molecule, we call it as a intramolecular. Within a molecule, we call it as a intramolecular rearrangement. Okay, so if rearrangement takes place within a molecule, we call it as a intramolecular rearrangement. If rearrangement takes place between two molecules, we call it as a intermolecular rearrangement. Okay, so what is the intramolecular rearrangement? Intramolecular rearrangement means within a molecule. See, tautomerism sorry, in tautomerism rearrangement takes place within a molecule. That means in the same molecule rearrangement is taking place. That's why we are calling it as a intermolecular rearrangement. Okay, so the two tautomers have different function groups. Two tautomers means keto form and enol form had two different function groups. See here, in keto form the function group is keto. That means C double bond O is the function group. In enol form the function group is C double bond OH. Okay, so I think this point, fourth one, is also clear. And yeah, fourth one is tautomers are in dynamic equilibrium with each other and interconvertible. We already know that tautomerism forms dynamic equilibrium which is interconvertible with each other. Okay, so next one is tautomer has no effect on bond length. So tautomerism doesn't have any effect on bond length. Okay, it doesn't shows any effect on bond length. And next point is compound should have electron withdrawal groups such as keto, nitro, cyano, ester, etc. So for tautomerism, the compound should have electron withdrawing groups. So keto, nitro, cyano, ester, etc. And next point is compound should have at least one acidic hydrogen on alpha carbon of the molecule at alpha position to conjugated system. So these 2 points are very important. For tautomerism, compound should have electron withdrawing groups and alpha hydrogens. Okay, compound should have these 2 characters. So for example, if we see these molecules, see here CH3 C double bond OH. This is the function group. Keto is the function group. Adjacent carbon is alpha carbon. The hydrogen attached to the alpha carbon are called alpha hydrogen. Here this compound had 3 alpha hydrogens. See, three hydrogens are present. CH3. So 3 hydrogens. So that means this compound had a electron withdrawing group. This is the electron withdrawing group and 3 alpha hydrogens. That means this compound shows keto enol tautomerism or tautomerism. See here, this is the electron withdrawing group here. So and here 3 alpha hydrogens are there, and here also 3 alpha hydrogens. That means total this compound contains 6 alpha hydrogens. That means this compound also shows tautomerism. This is very important. Very important in examination point of view. They might ask you which of the following compound shows tautomerism. Okay, so for that you should point out whether there is an electron withdrawal group present or not, and the second condition is alpha hydrogens are present or not. if alpha hydrogens are present, those are saturated or not. You should remember these three conditions. Okay. So in the next case, here electron withdrawing group is nitro. See, NO2 is the electron withdrawing group. So if electron withdrawing group is keto, then only we called tautomerism as a keto enol tautomerism. Otherwise we called it as a tautomerism. Okay. See here nitro. See, this compound had 2 alpha hydrogens. These alpha hydrogens are saturated. So this is this compound also shows tautomerism. And the next example is CH3, CH, CH3, cyano. See here, this is the electron withdrawing group. Here electron withdrawing group is cyano. And adjacent to this function group is CH. So this carbon is the alpha carbon. This alpha carbon had only 1 alpha hydrogen. So this compound also shows tautomerism. Okay. Next example, next point is, if compounds has active methylene or methane group, then tautomerism is shown by hydrogen of these groups. That means if a compound contains active methylene groups or methane groups, so those methylene or methane groups shows or participates in keto enol tautomerism. See, for example, AA, acetyl acetone. So here CH3, C double bond O, CH2, C double bond O, CH3. This CH2 group we called as the active methylene group. Okay. So why? Because this is present in between 2 electron withdrawing groups. See, this is the one electron withdrawing group and this is another electron withdrawing group. So this is more acidic. So active methylene groups are more acidic. Acidic means it's easily lose their hydrogen atom. So this methylene group participates fastly in tautomerism. Okay. In the same way here, this is the active methane group. So this one participates in tautomerism. These are electron withdrawing groups. Here one is there and another one is here. So okay. So if compound has active methylene or methane group, then tautomerism is shown by hydrogen of these groups. See, active methylene or methane group shows or fastly participates in tautomerism or keto enol tautomerism. Okay. And next point is, in both tautomers, number of sigma bonds, pi bonds, lone pair of electrons are always same in both tautomers. Tautomers means the resulting compounds are called tautomers, right? So for example, if we take CH3 acetone in the last example only, previous example only, say double bond O, CH. Here tautomerism means migration of alpha hydrogen. See here, this alpha hydrogen is shifting from carbon to oxygen. 5 bond is moving from here to here. The resulting compound is, and where is blue? Okay. See, H double bond, C OH single bond, CH. Here. So what is this next one? Number in both tautomers, number of sigma bonds, pi bonds, lone pair of electrons are always same. See, we will check it whether are they same or not. Okay. See here, first we are calculating number of sigma bonds. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 9 sigma bonds. Okay. And here see, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, here also 9 sigma bonds. Then 5 bonds. See, here 1 5 bond. Here also 1 5 bond. Here also 1 5 bond. Okay. Number of lone pair of electrons. See here, oxygen contains 2 lone pair of electrons. See here 1, here 1. In the same way, here 1, here 1. So lone pair of electrons, 2 lone pair electrons. Okay. Here we are saying lone pairs, and pair means 2 electrons. Okay. 2 lone pair electrons. Okay. 2 electrons are different, 2 lone pair electrons are different. Here we are saying pair. Okay. So this point also clear for you. Okay. In both tautomers, number of sigma bonds, pi bonds, lone pair of electrons are always same. Next one, tautomer is a chemical phenomena which takes place only in liquid state. So always takes place in liquid state only. Okay. Tautomerism always takes place in liquid state. Tautomerism is catalyzed by acids as well as bases. So tautomerism is catalyzed by acids as well as bases. And the next very important point, this is in competition exam point of view. So 12th point is, what is that? Compounds have finite structures don't show tautomerism. Okay, so compound having finite structure don't show tautomerism. These structures are called finite structures. Here the functional group is C-double-bond-O. Here is the functional group. Adjacent carbons are alpha hydrogens. So this is the alpha carbon and this is the alpha carbon. Alpha carbon contains one hydrogen here, one hydrogen here, and this is the keto functional group. Adjacent, this one is alpha carbon. Attached hydrogens are alpha hydrogen. Here also alpha hydrogens are there. See, here according to the tautomerism rule, compound should have electron withdrawing groups. Here one electron withdrawing group is there. Here also electron withdrawing group there. And second point is, it should contain alpha hydrogen. See, here alpha hydrogen is there, alpha hydrogen is present, alpha hydrogen is here, alpha hydrogen is here. And third condition is, hydrogen should be saturated. That means it doesn't attach it to the unsaturated carbon. But see here in this example, the hydrogens are unsaturated. That means this carbon atom is unsaturated carbon atom. So that's why these finite structures doesn't involve in tautomerism. Okay. The compounds having finite structure don't show tautomerism. Okay, these hydrogen atoms are sp2 carbon attached hydrogens. For keto-enol tautomerism or tautomerism, hydrogen should be saturated. Okay, is it clear? And this examples also, this is the electron withdrawing group. Adjacent to this one is alpha carbon. Alpha carbon contains alpha hydrogens here also, and the same way here and here. Here with electron withdrawing group is NH. Sorry. So this is alpha carbon, alpha hydrogen, alpha carbon, alpha hydrogen. Here also same. So hydrogens are unsaturated hydrogen. So these compounds doesn't involve in tautomerism. So if you see any question which of the following shows tautomerism or which of the following doesn't shows tautomerism, so in that case we should watch three conditions. First one is whether the given compound contain electron withdrawing group or not, and second condition is if electron withdrawing group is present, whether the compound had alpha hydrogens or not. If alpha hydrogen present, whether they are saturated or unsaturated. So if we check these three conditions, if three conditions are satisfied, then that compound shows tautomerism. If these three conditions, any one of these three conditions is not satisfied, that means that compound doesn't shows tautomerism. Is it clear? So based on these rules, we will see few examples whether they show tautomerism or not. Okay. So here the first example, say CH3, C, CH3, CH3, C double bond O, H. See, according to our rules, compound should have electron withdrawing group. Okay. So here electron withdrawing group is this one, keto. Electron withdrawing group is present. Okay. Adjacent carbon is alpha carbon. This is alpha carbon. So second condition is alpha hydrogen. The carbon should have alpha hydrogens. See here, carbon attached to are bonded with 3 methyl group. There is no alpha hydrogens. No alpha hydrogen means no tautomerism. Okay. The same way, see here in this compound, electron withdrawing group is nitro. This is the electron withdrawing group. Adjacent, just adjacent to this electron withdrawing group, this is the alpha carbon. Alpha carbon is bonded with methyl group, here methyl group, here phenyl group. Hydrogens are no. So no alpha hydrogen. That means no tautomerism. Okay. And the last one is, see here, electron withdrawing group is cyano. Electron withdrawing group. So adjacent to this electron withdrawing group, this is the alpha carbon. alpha carbon is bonded with 3 phenyl groups. Here 1, here 2, 3. So there is no alpha hydrogens. That means no tautomerism. Okay, is it clear? This is all about tautomerism. So in next class we will see enol content. In entrance point of view, enol content is very important. We will see in next class enol content, and we will discuss few examples on tautomerism. Thank you.